That video is cut short, and evidently I'm not tech savvy enough to turn that video's right direction, so I apologize for that. But to continue on, um, I was describing about how when we get the square root of any of the numbers in column 1, if it comes up a decimal, that's not going to be a new prime number formation. But when we get the square root of any of these numbers and it does come up a whole number and not a decimal, that will be the next number in the prime sequence. So 25, when we get the square root, is 5. It's going to be the next number in the prime sequence. 49, we get the square root of 49 is 7. 121, 11. Okay? So anytime we get a whole number and getting the square roots of anything in column 1, that gives us the next number in a prime sequence. And the sequence can't continue beyond this point without that number. So when you're filling in a graphing all this out, and you start coming up with empty spaces, well, life doesn't have empty space. It fills space, coming outward from a center, from 1. This, as I said before, will describe a doubling circuit, and you'll see that later in later videos. But what's important to know is that every time we come to a hitch and we can't fill in our sequence anymore, it's going to stop on one of these numbers. And when we get the square root of it, it's going to give us the next number in our sequence so that we can completely fill in the chart. We will see that as we jump over here, we can predict what these numbers are going to be over here as we come around with our 5s, right? 5 times 1 is 5. 5 times 2 is 10. 5 times 3, 15. 5 times 4, 20. 5 times 5, 25. We just discussed that as we came around. 5 times 6, 30. 5 times 7, 35. And we hit again in quadrants 1, 5, 7, or 11. Now, to get this 35, we had to multiply 5 by 7. These are all primes and prime quadruplets, so to get this 35, the multiplying number of 5 has to be the next prime number in the sequence. So if I'm jumping on out, say I jump on out and I'm out here at 119. Well, 119 is a multiple of 17 and a multiple of 7. So when I say 7 times what equals 119, 7 times 17, I know that 17 is going to be a number in my prime sequence. And if I multiply 17 times 17, that product is going to show me where the breakdown is without including 17. Our breakdown here happens at 25, 49, 121, square root is 11, 169, square root is 13. And then these numbers have to be included to continue filling in completely this chart. So I can actually predict what the next prime numbers are going to be simply by multiplying my 5s out. It gives me my 7. As I'm multiplying my 7s out, what are the multiples of my 7s that hit in these 4 quadrants? This gives us the next numbers in the prime sequence. We can predict where the sequence is going to break down and what number fixes it. I kind of feel like I could drop the mic right there on prime numbers, prime sequences, how they are the shadow of a geometric progression, the negative side of matter. And I believe this is, like I say, the say all end all of prime numbers. There's much more to explain about this, and it will take a whole book of videos, and I certainly hope I get better with video editing skills. I'll talk to my daughter. She's 12 years old. She's probably already on top of this. I didn't have her here right now. So, again, I apologize for the bad video, but the information is good and can be explained in much further detail. Please comment in the section below, and please try this for yourself. Math doesn't lie.